and here we have a general scheme of ANOVA. And before we start the computation of ANOVA, we need to have a quick look at the general scheme of analysis of variance, that how this is done. So for that purpose, we need to consider the key points that we have discussed in detail. ANOVA is the analysis of variance, so keep that in mind. And it is used as a single test instead of multiple testing for comparison of more than two groups or treatments, because the t-test allows only for the comparison of two groups. But if we want to have comparison of more than two groups, then what we are going to do, are we going to do the multiple testing and increasing our chances of making a type 1 error, or in order to correct the type 1 error for multiple testing, are we going to increase the chances of making type 2 error? No, we are going to use ANOVA for the comparison of the mean values, because it allows us to do that in a single test. So there is no need to do multiple testing, rather we can use a single test, the analysis of variance. And because this is analysis of variance, so basic focus of this analysis is the estimation of variability, and estimation of variability between samples and variability within samples. And as we saw previously, that why this comparison is important, because this comparison between the within samples variability and between samples variability. So this comparison gives us the clue of whether the mean values are significantly different or no. So that is why this comparison is important. So ANOVA allows us to see the effects of more than one predictor variable on a single response variable. So if we have more than one predictor variables and we want to see their effects at the same time on the response variable or the measurement variable, then we can do that through ANOVA. So these are the key points to remember. And the ANOVA computation revolves around calculation and analysis of variances. So we need to have the formula of variance to understand the concept. So the formula for variance is summation x minus x bar whole square divided by n minus 1, right? So this is a general formula for calculating variance. Now, what is x here? X are the observations, and what is x bar? X bar is the mean value. Right? So x minus x bar means the deviation of observations from the mean values, that how much the observations deviate from the mean values. And we calculate this deviation of observations from the mean values for all the observations. Let's say we have 100 observations, so we are going to calculate deviation of mean for each one of these values from the mean value. And then we take the square of these individual deviations from the mean values, right? So this is the square of deviation from mean value. And when we take the sum of the square of deviation from mean value of individual observations, that is known as the sum of squares. And what is n? N is the degree of freedom. N is the number of observations, so n minus 1 is the degree of freedom. So the simple, in simple words, the formula for variance is the sum of squares divided by degree of freedom. So because in analysis of variance, we have to calculate, or we have to estimate variances, so therefore we need to calculate the sum of squares and the degrees of freedom, right? Because so that we can have a comparison of variances. So the analysis steps in ANOVA, they are accordingly partitioned, right? That we have to calculate the sum of squares, we have to calculate degrees of freedom, we have to calculate variances, and then we have to do the comparison of variances. So here we are, that we have to calculate the sum of squares. So this is one part of the ANOVA analysis, that we have to calculate the sum of squares. And we calculate the sum of squares for the total sum of squares, and we calculate between sum of squares, between samples sum of squares, and then we calculate within samples sum of squares. So we calculate three types of sum of squares. So this is one part of ANOVA. The second part of ANOVA is to calculate degrees of freedom. And we calculate degree of freedom for total, and we calculate degree of freedom for between, and we calculate degree of freedom for within, right? So we calculate degrees of freedom for each of these sources of variability, right? And remember, the total variability is the sum of variability between samples and variability within samples. And then we have to calculate variance. Now, what two variances are we going to compare in ANOVA? We are going to compare between samples variance and within samples variance. So therefore, we are going to calculate between samples variance and within samples variance. And for that purpose, we have already calculated their respective sum of squares and degrees of freedom. And in the end, we have to do the comparison of variances. So we have calculated between samples variance and within samples variance. And now it is time to compare these variances, because as we saw previously, that this is the comparison of the between samples variance and within samples variance that gives us the idea that whether the mean values are different from each other or no, right? So we have to compare these two variances, and this comparison is done through F-test of ANOVA. And this test is used to tell the significance of difference between the mean values. So this is how ANOVA is done, and the ANOVA is partitioned into calculating the sum of squares, calculating degrees of freedom, calculating variances, and calculating the F value. So this is how ANOVA is done. Now, you have a quick task to do before we move on to the ANOVA computation in our next lecture. And that quick task is that you have to document nominal variables and measurement variables with examples from daily life, right? So you don't have to take examples from biology, because we have already discussed a few examples from biology in our previous lecture. So you don't have to take the examples from biology, rather you have to take examples from daily life. And why this is important? This is important because you need to have a complete understanding of the design of the experiment or the concept of ANOVA, that what are the nominal variables, what are the predictor variables, and what are the measurement or response variables, and where we can apply ANOVA into our daily life as well. So unless and until you have this clear concept in your mind about the role of the variables, you cannot do successful ANOVA, or if you can do ANOVA, you cannot successfully interpret the results of ANOVA, right? So you have to document these examples, and we are going to discuss these examples in the question and answer session of this lecture.